what we have done is, we have done the standard equation of a circle, we have then studied the general equation of a circle, and then we figured out how do we calculate the center and the radius from the general form of a circle. Now in this, here now what we are trying to do is, we are trying to calculate the equation of a circle when the endpoints of the diameter is given. For example, let us consider a circle which is passing through the two ends of a diameter. Let us say this is a center and this is a point A and this is a point B. The coordinates of A is given by x1, y1, and the coordinates of B is given by x2, y2. Now, how do you think we should go ahead to find out the equation of a circle? Now, we have already seen, in order to find the equation of a circle, we need the center and we need the radius. Now here, since we have the two ends of a diameter given to us, we can easily calculate the center by using the distance, by using the midpoint formula, and then we can calculate the radius by using the distance formula. So let us try doing it. So we will do this derivation by using two methods. One will be using the property and one with using the knowledge that we have gained till now. So let's first give it a heading: circle whose two ends of a diameter is given. So this will be our method 1. So in method 1, first we calculate the equation of the center, which is given by the midpoint formula x1 plus x2 by 2, comma y1 plus y2 by 2. This is the center. Now what will be the radius? Radius will be half of the diameter. So the diameter is the distance AB, which can be calculated by using distance formula. So AB is nothing but under root of x2 minus x1 whole square plus y2 minus y1 whole square, and this we have to multiply by half because we are trying to find the radius. So let's AB by 2. This will give us the radius, let us say r. So the equation of the circle we will have, let us recall the standard equation, which is x minus h whole square plus y minus k whole square is equal to r square. Now substituting the values, we have x minus x1 plus x2 upon 2 square plus y minus y1 plus y2 upon 2 whole square, and equal to, instead of r square we can write this. So we can have 1 by 4 outside, and then we will have x2 minus x1 whole square plus y2 minus y1 whole square. So let us try to simplify this and come to an equation in a particular kind of format which is very convenient for us to understand. Now if we take LCM here, what we will have here is 2x minus x1 minus x2, and we can take the denominator out, so we will have 1 by 4 outside. The same thing will happen here. So we can easily cancel out 1 by 4 from everywhere. So the next step, if I write in this way, we have 2x minus x1 minus x2 whole square plus y minus y1, 2y minus y1 minus y2 whole square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Now we'll do some rearrangements here so that we can solve this very easily. So let us do these some replacements here and some additions and subtractions. Let us see what. So what we do here is we write 2x as x plus x, and then we use x for 1 for x1 and 1 for x2 in the particular way. So we have x minus x1 plus x minus x2. Now easily if you look at here, x plus x will give us 2x, we have minus x1 and then we have minus x2. So this term is the same, it has not changed, just the arrangements has changed. Now here what we do is in a similar manner, y minus y1 whole square plus y minus y2 whole square and the bracket closed. Here what do we do? Now here what we will do is we will add 1x and we will subtract 1x x. So let us see how. So if we write this as x2 minus x and then we write plus x minus x1 and then we put a square. So the idea is minus x plus x cancels itself and what we have is nothing but x2 minus x1. And then for the last remaining term we have again y2 minus y plus y minus y1 whole square. Let me put a bracket here. Now the idea is to have terms which look similar to each other on both sides. So what do we get if we simplify this? So let us see the next step. So a plus b whole square is x minus x1 whole square plus x minus x2 whole square plus twice of x minus x1 times x minus x2. This is the expansion from the first term. Next we have y minus y1 whole square plus y minus y2 whole square plus twice of y minus y1 into y minus y2. So this is on the left hand side. Then let us expand the right hand side. So we have x2 minus x whole square plus x minus x1 whole square, and then we have plus twice of x2 minus x into x minus x1. What I want to do is I want to write x2 minus x as x minus x2 as x minus x1. So what I'll have to do is take a minus common. So here we'll have a minus 2 and then we are left with is x minus x1 times x minus x2. Doing the same for the last remaining term, y minus y1 whole square plus y2 minus y whole square is same as y minus y2 whole square. So we can write that, and then we have the last term 2 times y minus y1 into y minus y2. After having done all these hard work, it is now time for some cancellations. So x minus x1 whole square and x minus x1 whole square gets cancelled. Similarly, x minus x2 whole square and x2 minus x whole square gets cancelled. You know, we can interchange because we will have to take a minus sign, and because there is a square, minus minus becomes plus. Y minus y1 whole square, y minus y1 whole square, y minus y2 whole square, y minus y2 whole square cancels. So what we are left with is 2 times x minus x1 into x minus x2 plus 2 times y minus y1 into y minus y2 on the left, and on the right side we have the same term only with a minus sign. So if we shift all of this to the left, what we are left with is nothing but 4 times x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. We can easily remove this 4 constant. So the final step for us in this case is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Now this equation is a really interesting equation, and it has been written in a very intelligent way. The idea here is simple. We have two x coordinates, x1 and x2. So we are just subtracting those x1 and x2 from x and multiplying them. Similarly, we are doing it for y. We are adding them and we are putting this equal to 0. So that is how you get the equation of a circle very easily. So let us say someone asks you a question. The question is, if there are 2 points, let us say 2, 4, and another point is, let us say 4, 10. And the question is, how do you write the equation of the circle? So you do not have to calculate the center, you do not have to calculate the radius. What you have to simply do is substitute in place of x1 2, in place of y1 4, in place of x2 4, and in place of y2 10, and you will simply get the answer. So it has been written in a way so that it is easy to remember and it is very easy to calculate. So what we have done is, we have found the equation of a circle whose 2 ends of a diameter was given to us. So let us say this is our method number 1, which was by understanding of the concepts which we had till now in the previous class. Now what we are going to do next is we are going to derive the same whole equation using a very easy property which we have studied in our previous class, and we will see how the property makes it so very simple for us to get this whole equation. Now we will do this derivation, we will do this equation of a circle when the 2 ends of a diameter is given to us by using another method, or by using a property of a circle which we have already studied in standard 10th. So let me just write the standard equation that we had for this case. So the equation we derived was x minus x1 times x minus x2 plus y minus y1 times y minus y2 equal to 0. So this is the equation in this particular case. Now let us see if we can do this by another method. We will definitely be able to do it. So how? So if you remember, we have studied in a circle, if we take any point on the circumference, then the diameter of the circle subtends an angle of 90 degree. Any point if we take on a circle, circumference on the circle, any diameter is always going to subtend 90 degree at that point. Let us say this point is P. Now if we have this point having coordinates, let's say x, y, you can understand that this point will, can lie on anywhere on the circle. So if we find this condition, if we put this condition of 90 degree using A, P and B, we will get the equation of a circle which will come out to be this. So clearly we know by the knowledge of straight lines that if two lines are perpendicular, then let us say if line 1 has a slope m1 and line 2 has a slope m2 and they are perpendicular, then the product of the slopes for the two lines will be equal to -1. Now in this case, let us say Our line 1 is AP. So slope of the line AP can be calculated by using the formula y2 minus y1 by x2 minus x1, which will be y minus y1 upon x minus x1. Again, the slope of the line PB can be calculated by again using the same formula, and we will have y minus y2 divided by x minus x2. You can take you can interchange these two, but it does not matter, because if you take interchange, you can anyways take a minus sign common from both the numerator and denominator, which will cancel out and you'll get this. Now, since the product of these two slopes has to be equal to minus 1, we can write MAP into MPB will be equal to minus 1. So we have y minus y1 upon x minus x1 into y minus y2 upon x minus x2, and that is equal to minus 1. So if we just rearrange them, what we have is y minus y1 into y minus y2 is equal to minus of x minus x1 times x minus x2, and we can take this term to the left hand side, and what we get is x minus x1 into x minus x2 plus y minus y1 into y minus y2, and that will be equal to 0. So we have again derived this equation. Now this time fairly very easily compared to the last time, because of the simple use of the property of the circle, which we have studied in standard 10th. So these properties are always going to be very, very useful and handy in solving questions if we apply them at the right place and utilize them properly. So now this is a formula in case of a circle whose two ends are given. Now, as explained in the previous method, now this is a very fairly easy way to remember. Try solving many questions based on this and trying different ways to get the answer by using different methods, which will help you to have a better understanding of what is going on. Now, I would also suggest you to try to draw the equation, try to draw the figure of the equation which is given. Now, when you find any equation, you can always find out the center and you can always find out the radius. Try drawing it and visualizing it. It will help you understand the coordinate geometry and the chapter of circles in a much more better and strong way. So that is it for now.